Yes, welcome back again to the next session. Here we will reach the equation for a parallel plate capacitor with a dielectric slab between the plates. It's a special type of question asked, like this is the case. So you have a parallel plate capacitor. Actual separation between them is D, and one plate is positive and other plate is negative, and the area of the plate is A as before. Now what you do is you are taking a dielectric slab of thickness T and dielectric constant K, and you are placing it over there. In between the plates you are placing one another dielectric plate of constant K. Okay, now we want to find what is the capacity of that arrangement. We will proceed as before. Charge given is as usual, it is equal to Q. Charge given is equal to Q as it is. Now we need to find the potential difference. Potential difference is nothing but the field into perpendicular distance, right? That is the potential difference. Now total potential difference will be potential which is existing at air and potential which is existing at medium. Potential difference which is existing at air plus potential difference which is existing at medium. The sum of it will be the total potential difference. Now potential difference in air is electric field existing in air into separation, like thickness of air. Thickness of air is D minus T, isn't it? Why? D is the total separation between the plates. Among that, T is medium. So the air thickness will be D minus T plus electric field with the medium into T. And electric field in air is sigma by epsilon 0 into D minus T plus sigma by K epsilon 0 into T. You remember that? That expression I introduced in the last definition itself. So you can take sigma by epsilon 0 out into D minus T plus T by K. That's it. D minus T plus T by K. This is what the equation for the total potential difference existing between the plates. Now what you find is the capacity of that arrangement, which is the charge given Q divided by total potential difference, which is sigma by epsilon 0 into D minus T plus T by K. Now you know what Q is nothing but sigma A. Why? Sigma is equal to Q by A. So Q equal to sigma A. So sigma A divided by sigma by epsilon 0 into D minus T plus T by K. So this sigma will be cancelled. It will be A epsilon 0 divided by D minus T plus T by K. This is the expression for capacity of a parallel plate capacitor with a dielectric slab between the plates. Now there can be different special cases. One, if instead of dielectric use metal plate, if it is a metal plate, for metal plate K equal to infinity. For metal plate the dielectric constant is infinity. So capacity will be equal to A epsilon 0 divided by D minus T plus T by infinity. Something by infinity is 0. This will be A epsilon 0 divided by D minus T. Now if it is fully filled, with dielectric, right? Now instead of small thickness T, if it is fully filled, then you can say T will be equal to D itself. So capacity will be equal to A epsilon 0 divided by d minus, instead of t you will write d minus d plus d by k. So d minus d is 0, that will be A epsilon 0 divided by d by k. So capacity is equal to k A epsilon 0 by d. Yes, this one we already reached before. If the space between the plates is completely filled with dielectric medium, the capacity is k times the capacity due to Ercot capacitor. So this is the capacity of a parallel plate capacitor with a dielectric slab between the plates. See, there is one another type of capacitor which is a cylindrical capacitor. Actually, it is not that important in our syllabus. Still, I will directly give you an equation, that's all. See, this is in the inner cylinder of radius A, and this one is outer cylinder of radius B. Now the outer cylinder is earthed. This is positive charge and this is negative charge, suppose. This is a cylindrical capacitor. The capacity you just take it as one equation. It is 2 pi epsilon 0 L divided by log B by A. 2 pi epsilon 0 L divided by log B by A. That is the equation for cylindrical capacitor. Just one expression. Actually, it's not that important, but there is a mentioning about cylindrical capacitor in NCERT book. That's all. So please don't forget to subscribe the channel, and if you need any live class, you can call me in this number 9846 334982. I'm giving tuition at my place, which is near Civil Station, Calicut, Kerala. Thank you.